Hi, my name is Michael, and Sean and I made an impact detecting football helmet. The purpose of this device is to collect data about the accelerations and rotational velocities that players' helmets experience in gameplay to help predict and prevent concussions and brain damage. The device collects data from the accelerometer and gyroscope on the IMU, turns on a green, yellow, or red LED based on how hard it detects a hit, and then sends that information to an MQTT feed. Meanwhile, another Python script on the computer reads that MQTT feed and formats and uploads the information into a Google spreadsheet. So here's a few photos of our prototype. It's obviously much larger. A real implementation would likely have the electronics smaller and more protected. It's powered by a portable phone charger, and then in the back you can see the green, yellow, and red LEDs. So here's a quick demo of the device. It's detached from the helmet just to make it easier to shake around. So yeah, I'll just shake this guy and start collecting some data, and it should be popping up on the Google spreadsheet in real time. Shake it around just a little bit more, and then I'll talk about the data. So now taking a look at the data, a new row is recorded in the spreadsheet whenever any axis for either sensor records data within the predetermined thresholds. These thresholds are chosen arbitrarily by us in order to collect and display data. They're actually at a much smaller scale than would be implemented in real life. So each row displays the date and the time. It shows the X, Y, and Z axes for both the accelerometer and the gyroscope. And then it highlights that specific cell, either green, yellow, or red, based on which threshold the sensor recorded that data at. And these thresholds are supposed to, in theory, indicate a certain level of danger in terms of how hard the impact was, green being not as dangerous and then red being the most dangerous. Okay, so here's a very brief overview of how the code works. The main two Python files are ACC test2, which is running on the ESP32, and connect sheets, which is running on the computer to connect to the Google spreadsheet. We also have boot.py from lab 1 and the 3 IMU files from lab 7. So looking first at ACC test2, it's just going to connect to Wi-Fi and the MQTT like in previous labs, define the variables for the pins and the IMU, and it's going to maximize the range for the IMU for the accelerometer and the gyroscope to plus or minus 16 Gs and plus or minus 2,000 degrees per second respectively. Initialize some timer variables and define a callback function, which I'll talk about in a second. And then it's just going to run the callback, define the callback function for the main loop for the entire program, where it's just going to save all the accelerometer and gyroscope readings, define the triggers, or define the thresholds for the triggers. So between 2 and 4 is green, 4 and 6 is yellow, and 6 plus is red for the accelerometer. And then it goes 1,000 to 1,400, 1,400 to 800, and 1,800 plus for the gyroscope. Then it's going to just run through these 3 if statements to determine which threshold the readings fall within. I'll just go through one of them because they're all the same. So for this one, it's going to check if the X, Y, and Z for the accelerometer and the gyroscope are within the threshold. If it is, it will turn on the green light. Start this timer for 1 second where the callback is to turn it off. So that's how we got around turning the lights on for a second without pausing and sleeping the entire function, the entire program. It's just going to save some variables, and then it's going to send all that data to MQTT. Then to connect sheets, we're using the Google Spreadsheets API, which we found online. It's just going to connect to MQTT, subscribe to the MQTT feed where the callback function formats the data into a row, it inserts the date and time, and then inserts that entire row into the spreadsheet, and then colors the cell background based on which threshold the readings fall between. Okay, and lastly, just in the spirit of Internet of Things, we're going to show how me with the device in San Diego right now can trigger the sensors, and then Sean should be able to read the output in real time from his phone in Chicago. So let's get this to trigger some outputs. And as you can see, the different accelerometer readings, along with which axes they're popping up on, along with which colors, are all showing up on Sean's phone.